Alrighty, hello everybody. Today we're going to do a tutorial on how to parameterize using SpaceClaim and ANSYS Fluent. Today's example will cover changing the angle of attack of two front wing elements. Jumping into SpaceClaim, I've already got our mesh section up because we'll be using ANSYS meshing for this process. You just select that for me and drag it up. Get rid of that. Yeah. So the SpaceClaim is already open, and I'm already downloaded my file just by going File, Open, and whichever step file you wish to import. So here we go. There's our two front wing elements. We're going to create an enclosure by going to Prepare, click Enclosure, click and drag. Then make sure symmetrical dimensions are switched off. For our dimensions for our enclosure, we want to go take the length of your geometry. You want that to be the distance above, below, side to side, and in front, like this. And then you want 3 times that length at the rear. 3 times 5. Right, when you're happy with that, just click the green button and your enclosure is instantly created. And then over in the structure tree, you can deselect these two components now. Make sure you are back on select. Click those two, and we're going to suppress those for physics. And when you suppress for physics, it just means that Fluent won't be able to complete any calculations on them, and it basically just ignores them. That's what we want. We're going to create some name selections now. So click on the front face, Control G, and that will create a group. I'm going to name that. Control click all these faces. And that's going to be and then also the rear, that's going to be so we can now, to access the actual aerofoils, we're going to hide this guy. We'll click it here, and then hide that face, and then we can do name sections for this. So this one here is going to be just click and box select the whole ice. Make sure you get all 4 faces. That makes it so much easier. Face. I did that for several weeks. It's a waste of time. Anyway, so name sections are now done. Now we are going to move on to using the Move tool to create our parameters. So, move, box select, and that now we can move up side to side, back to front, or we can change the angle to do first. So that to 0, and we're going to go Control D to create a parameter. This one is going to be 1. We're going to do the same for this one. Control D. Right, now each time we change our angle of attack, it's going to change the position of the airfoils in relation to the rest of the enclosure. And this can cause a few issues. So we need to have some references so we can control the position of our airfoils for each iteration. This is where things can get tricky with this process. This is the only difficult part of this process, in my opinion. Meshing is here or there. You need to make sure that the order you do this in ensures that your geometry never overlaps when updating. So overlaps, it's going to fail, and just right. Also, when you do, you're going to notice that our triad is not in an orientation that's useful to us. We can't really do anything here. What I've noticed is that if we just move it forward a little bit, it fixes it. So now when I click here, it's exactly how I want it to be. Amazing. So that's a quick fix for that. I'm also going to find that when we do the second element. I'll show you how to fix that as well. So I'm going to click this up arrow, select ruler, and then reference it off the bottom. 80, and then Control D. This one's going to be called a reference. I'm going to call it high. So that's going to determine how high is that tail edge going to be of that front element. The reason we want that is to reference the gap, and we can determine how high is the second element going to be in relation to the first one. However, when you make sure that your triad is in a logical position. At the moment, you can see that's kind of angled upwards. And so, you know, it's not, you can't even reference it to the bottom, which is not great. And it can cause a fair few issues. See, can't reference it. So we're going to undo. What we want, I found that if we move this slightly to the side, and we select it's perfectly orientated. So just make sure that that's correct, otherwise you're going to come into a few issues. So now that's done, we can now select this arrow and reference just like we did before. Let's set that one to 5.9. Let's set it a little bit higher. D, and that. Awesome. Now we're going to do the same for the distance from the front face. We're going to get green arrow this time, ruler, reference it off this bottom edge. You can't do it off the face, it just strictly doesn't work. If you try to do that, you'll just get an error. So you have to make sure you're referencing edges to edges. That's how you want to do this. Oh, I forgot to. All right. Also make sure that you remember to create the parameter. The amount of times I do that is ridiculous. So this one I'm going to call. Sometimes I use reference 1, reference 2. I feel like height and different distance are also good descriptions. Then we need to do the same process. Reference it off the same position. Yes, you to be 9. Control D to create the parameter. That one's going to be cool. So now, when we update these in our design points, it's going to do it in the order. So it's going to change angle attack first, and then it's going to change this height, and then this one, and then the height of the second element. Then it's going to determine the distance of the first element, and then the overlap. In this order, you should not see any overlap of the two geometries. When you get overlap is when you get failures, and that's not something you want. To quickly check, make sure everything's working, you can link Excel as an add-on, simply by just going SpaceClaim options, go to add-on, add-ins, and select Excel. And if you click create, it will create a workbook that allows you to automatically update your geometry. Super useful, and it just confirms that everything's going to change as we wish. So here we are. Let's say we want to go to 9, 27.5. We're going to keep the height the same, but I'm going to increase this to 602. So I want a gap of 22 millimeters. I keep the distance the same, but I'm going to increase this to 37 overlap. So that's 915 minus 22. Once you've made those changes, just click update, and it should automatically work. There we go. Sometimes if you mess up how you reference everything, that's when you're going to start having issues. So make sure you are very careful with how you do that. I'm just going to go backspace, go back to our original one. And you can see here what everything's set up. Lovely. So now that that is ready, we will move on to meshing. We can see it will come to the parameter set later. once we have set our output parameters. So we can open meshing. Technically, you could also use Fluent meshing if you have access to the watertight workflow. You cannot use the standard Fluent meshing workflow because that requires you to like manually import the size fields and set the prisms and all that sort of stuff. And you can't run that automatically. It just won't work. So we're just going to wait for meshing to open. Here we are. Lovely. I've heard I do like to avoid ANSYS meshing because it's just a finicky thing. Now, because I'm on the student version, because I'm filming this on my laptop, my mesh is going to be considerably less refined to what I would actually want. Keep that in mind. First step, we want to go and we want to include our two wings in the program controlled inflation. Include and include. What that means is that in here, awesome, lovely. Yes, so the program controlled inflation means that when we get to this part here, when we create the inflation layer, it actually creates it on those name selections. Basically cuts out the middleman of using the this inflation tool up here. It's awesome, it's great. Only good thing about ANSYS meshing, one might say. Anyway, so we're going to set the element size. I'm going super big, 0.5. I don't want too many elements. You might want to go with this. Sizing. You got to use sizing. Growth rate 0.2 is fine. 0.5. Work out curvature angle, proximity. Yes, yeah, we'll do that. Yes, we want 5 there. It's always a good thing. There is a very good video on YouTube, which I will link, which runs through a great way of doing this mesh, and it will go into much more detail than I do. Yeah, we have quality check for quality. No, we've got units. Cool. Right. We want to use program controlled inflation. This is the important part. The rest of it, we don't really care for. Program controlled, and we are going to go for first layer thickness. Now, in my standard simulations, I like to use 5.5 E negative. And I like to go for 10 layers. I'm going to run that here. It may not be a good idea. If you're using a proper system, definitely do that. Advanced. Right, maximum angle we want to be 180 degrees. Layer compression, you don't want stepping. It's not. And that's all seems good to me. Very good. All right, and then let's update, generate the mesh. I'm going to do a section plane just to quickly have a look at what's going on with our inflation layers, as possible, and boom. Oh, where are we? Let's get to zoom. There we go. There's our inflation layers. Nice. Captures the curvature at the end's pretty good. It's sufficient. As I said, you will want to do something much more high quality. Maybe also include a body of influence. You'll know how to do that from my other videos, but this will suffice for now. And the good thing about ANSYS meshing is each time we update our design points, this will be updated as well. So now our mesh is ready. We are ready to move on to Fluent. Link that there. Made it. Not important. Right, so just opening Fluent. So here we're going to quickly run through our setup, and we're going to create some output parameters. And those output parameters are going to be lift and drag. Oh, downforce and drag in our case. Oh, how about? Yeah, cool. Let it load in everything. Alright, there is our wonderful mesh. And another good thing about ANSYS meshing is that it automatically sets some of your boundary conditions. Right. First, we need to make sure we've got the K omega SST. Sorry, please. Let's have temperature correction as well. K omega turbulence model with SST with curvature correction. That's all that's good for me. So we don't care about there. All this is left as standard, nothing to worry about. Materials leave as standard. It's already air. Aluminium doesn't really matter. I don't think that influences us too much. We want only one fluid zone. This is where you make sure that your components were suppressed, because they'll pop in here as solid zones, and then you've got to go back. Right. All right. So inlet is going to be here. It's already been defined because of our name selections, and because ANSYS meshing is very nice like that. Let's just set the velocity magnitude to be 20. These turbulence values should be fine. I have found no issues at all. 0 gauge pressure at the start, perfectly fine. Apply that. Close. Leave the eternal. Don't mess with that. Just don't mess with it. Don't even open it. Go to the outlet. It's also going to be a pressure outlet. Nicely, ANSYS already knows that's what we want. 0 gauge pressure, because it's going to be on the atmosphere, is perfectly fine. Apply that. Close. And then our wall, our sky is only going to change. Our sky we want to set as a specified shear wall with 0 shear stress in all directions. So it's basically non-existent, but it contains the flow, but does not influence it at all. Apply that and close. Wonderful. Then we need to go to our reference values. Our area. Now our area is going to change as it goes. So let's compute inlet. Already got that in the area though. Let's determine this. We go to results, projected areas, y direction. Because this may be different for yours, but in mine the flow is flowing in the y direction. 0.02 is the current projected area. That is going to change with different iterations. So let's just set it to something like 0.1. Pretty small. Let's go 0.8. So just something that's in the same ballpark. If one is obviously way too much, it's going to be, incorrect. So set that. That's awesome. And we move on to methods. And you want the coupled, go auto select, that's perfectly fine. And you want least squared for the gradient, second order for everything else. Awesome, it's pre-selected. This is what we love about the updated versions. Now go into report definitions, double click that. You want to create a new force report, drag. It's over here, sorry. So our drag will be acting in the y direction because that's the way our flow is going. As you can see from this triad, it's down there. Now let's call this drag coefficient. 1, 2. Yeah, to me. And we're going to port file, print the console, And we're going to set this as an output parameter. Okay, love to see it. We're also going to create one for downforce. So this one you got to lift, because obviously lift is opposite downforce. Our downforce will be acting in the negative z direction. So yeah, negative z direction, like that. If you're unsure, just check. Your model may be different to mine with how the cardinal direction is set up. Make sure you double check that. Coefficient, and create output parameter. Awesome. Okay. So when you create these, you create them in the monitors, report files, report plots. Awesome. We love that. Now we're going to convergence conditions, and we're going to add two of them, and they're both going to be two we just made. And we're going to stop it when it gets, that seems decent. Depending, obviously, the stop criteria, the smaller you make it, the longer it's going to run for. Technically, the closer it's going to be. But like, it's close enough in this case. We want to ignore the first 20 iterations. And we're going to use every iteration. We want any condition met is perfectly fine. And just click OK. We want to initialize, and we're going to use hybrid initialization. Click that, let it do its thing. Initialization shouldn't take too long at all. Obviously, this mesh is very coarse, so it may not be sufficient. And then we're ready to go to run our calculation. Ignore that. We are not doing anything with transient, I believe. Should be no transient. No, it should be steady. Yes, comes up automatically. And we run this for like 200 iterations, blah, blah, blah. Love it. You can run it for more, 200 should be enough. So that's that. Now let's go into our parameter set. So in here, let me just move myself a little bit. So this is where you change everything. So you can change all your input parameters and it will spit out your drag coefficient. You could also, when I did this, I actually had these as drag forces. It would not be a bad idea to have both running. So let's actually add in, go back here. I'm going to add two more. I'm going to add drag and force, these two. And we're also going to add the difference. This is just so that you can know physically the force is not just the coefficient. Okay. Let's close this, and there we go. Now we've got our force in there as well. So what do we do now? Now we just set our things. What do we want everything to be? So let's say the first one test is 9 degrees, 27.5. Leave your height in your gaps standard pretty much. We only want to be changing the angles of attack. So I want a 22 mil gap. So let's make that 6.2. And I want that to be 22 overlap. So that's 115 minus 22. Oh, it doesn't recognize that. Okay, I thought you did math. That's okay. I can. Hold on. Yeah, minus 15. Yeah. 893. Easy. So that's going to be our first iteration. Let's say I just want to change the first one. Let's go and do that. These going to all be standard. And the only thing we're changing is the angle of attack of the first. So when we are ready, you can select which ones you want to retain. You can retain all of them if you want to go to psycho, I guess, but retaining the first and the last one are perfectly fine. In our case, our first one's actually that one. It's just the baseline. This is the first one we actually care about. And then you would go update all design points. And that, you'll then get your results. It will spit out all your drags, all your downforce, and then you can determine which wing orientation you would like. You can run as many of these different combinations as you want. You can change angle 1, you can change angle 2, you can change the gap, you can change the overlap. There's infinite possibilities. So I hope this video has been helpful. Stay tuned for plenty more. Thank you very much.